I hope you're fine. Today we're gonna talk about triangle congruence, CPCTC. So let's start. Remember, we took before when I say that triangle ABC is congruent to triangle DEF, this means that angle A is the first here angle is congruent to which angle here? The first one. I'm looking to the order of the letters. So here A is congruent to angle. Yes, it's congruent to angle D. And BC here segment congruent to EF segment. Let's have this one. Today we are going to talk about CPCTC to prove parts of triangles are congruent. So let's start. When I say CPCTC, it's very hard. No, it's the abbreviation for the phrase corresponding parts of congruent triangles are congruent. It can be used as a justification in proof after you have proven two triangles are congruent. Remember together, SSS, three sides are congruent to each other. SAS, two sides and one angle. ASA, two angles and one side. AES and HL here use corresponding parts to prove triangles congruent or not. Let's have example to know what we are talking about. Now you are in engineering. So A and B are on the edges of a raven. What is AB? When I have here AB, okay, I have here two triangles as we see. I have here first of all, I have here this side, it's 15, and the corresponding side, it's the same 15. Okay, and I have also what? I have here, this is 10, and this is 10. And this is 18, and this is, I don't know. And I have here one angle, what? This angle, vertical opposite angles, right? So I have two sides which are two pairs of sides are congruent, and I have here also two angles are congruent to each other. So the two triangles are congruent, right? So therefore the two triangles are congruent by SAS, two sides and one angle. By the CPCTC, the third side pair is congruent to the other. So AB is congruent to here, it's 18 like the other one, the third side. Okay? The landscape architect sets up the triangle shown in the figure to find the distance JK across a pond. What's JK here? I know that we have here, this is 19. Okay, JL is 19 and I have here LN is 19, while LK is 30 and LM is 30, vertical opposite angles. Then I have here the third side, MN is congruent to JK by the CPCT. Okay, let's have another question. YW, it bisects XZ. Bisects means that it gives me two equal sides. And I have here XY congruent given, congruent to what? YZ. So, and I have what else? I have a common side. Common side, so this side, it's the same like here. So I have three sides are equal, or so I have here what? So I have here SSS, the two sides are equal. So he asked the question, prove that XYW is congruent to what? Is congruent to ZYW. Of course, they are congruent because we have here two congruent triangles. Okay, the same idea here. Okay, using the CPCTC in a proof, but we don't have proof. He asks me here to prove that MN is parallel to OP. Okay, but we don't have the proof. It's not for you the proof. Okay, guys? Okay. We have here using CPCTC in the coordinate plane. Yes, this is for us. I have here some points given. D, -5 and -5, the coordinates of D and E and so on. So he asks me to draw I have to prove here that DEF triangle angle is congruent to GHI. So I have here two triangles I have to draw. Plot the points on the coordinate plane as seen here. Then here, when I say plot the points, to the ones who can't remember, I have -5 and -5. So on the coordinate plane I have x and I have y, -5 here, and then go down until -5. So this is D. And then E, -3 and -1, -3 here, and then go down at negative what, -1. This is E. And then F. After drawing, I will connect them to make a triangle, and here I will do the same. After that, he asks me to do what? He asks me to prove that DEF, and see, where is DEF? DEF, this angle, is congruent to which angle? GHI. GHI. I will see here, this segment will be how many units? So here between, here I have EF and GI. I will use the distance formula. I can use it from what? I can here count from the coordinate plane, or I can use the distance formula. The distance formula here, to find the length of the sides of a triangle, I have a specific formula that I should remember and study well. It's here the difference between x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. This is the distance. I am here calculating the distance. The distance here of D and E. So DE, between DE, how can I calculate the distance here? I will see D, it's a point with its coordinates, and E, it's another point with its coordinates, and it's written. And here, this is x sub 1, this is x sub 2, this is y sub 1, this is y sub 2. Then what should I do? I will substitute in my formula and then get, okay, the all under a square root. Okay, all squared under square root. Then I will get the answer, and this quarter we are using the calculators, it's okay. After finding here, I will find that I have here 2 square root 5, and I have here what? This is for DE, and I have here 2 square root 5, the same, we have here same side, okay, square root 5, and I have here square root 5, the second two sides, and I have square root 13, the third sides. So the third couple of sides. So this means that I have SSS. By SSS, the three sides are congruent. This means that I have here congruent triangles. By that, I can prove that the two angles are congruent. I have another question for you, for like an assignment that I will give you. I have here to draw also on the coordinate plane given, and then what should I do? Remember, I will find the distance between them. Okay, so if it's not very clear on the coordinate plane, the distance between the sides, the points, so I can use the distance formula. It's very easy, don't panic. I will use here the formula like this, the same idea. The formula, it's what? Let's revise this. I will write square root and leave it like this: x sub 2 minus x sub 1, the difference between x's, plus the difference between y's squared under square root. So you can study this like this. It's an easy way, don't panic. Okay guys, and that's it for this lesson. I hope you understood everything. Thank you for listening. Bye bye.